So thanks a lot for being here. I think what motivated me to do this podcast was because we talk a lot about AI these days, but not enough, in my opinion, the trust. Like, how do we know what's actually true online and who is out there building tools we can really trust? So that's why I decided to invite you, Paolo, to this podcast, because you are a data scientist in Recom, also someone who is working all around the world from Italy to Qatar and then in the US, always focused on the big question, which is how we can make data reliable and meaningful. So maybe before we dive in, I'd love you to maybe tell us a bit about yourself and what interested you in this idea of trustworthy data.
Right. So thank you guys for inviting me. And I'm a professor at Eurocom since 2017 now. And my background is in mostly in data management. That's what I've been doing for a long time. And indeed, I've been working a lot on data quality, as you mentioned at some point. This is indeed a topic that I always found fascinating because a lot of people spent a huge amount of time and energy creating strong models for prediction analysis, but it's very well known problem in the industry, real application that most of the time is spent to prepare the data, which is something that takes, according to different surveys, like 85% of the time when you need to run a project. So this data preparation includes data quality, and that's where I've been doing a lot of research.
Okay, because when I look at your research, because I've done some research in order to prepare this podcast, I've seen that you use a lot the term of scalable data management or data integration, but that doesn't sound bit, but that sounds a bit abstract to most people, and particularly to me. Would it be possible for you to explain it maybe in simple terms, what means data quality and what it is such a big challenge today?
Sure. So let me break it down. So when we talk about the data quality, we talk about trying to make the data fit for the final task, right? So one important facet, one angle is definitely the accuracy, the veracity, if you want, but there is more, like, for example, the completeness. So those are all different facets of this problem where you want to say, okay, is my data good enough to derive any conclusion? And so when I mentioned that it depends on the target task, it's because depending on the tool and the technology that you're using to do the analysis, to get the insight, you may be compromising with different levels of data quality. So for example, imagine that you're computing the average of the salary in your company. There is a case where you need to be quite precise because it's a kind of data where you cannot make mistakes, usually in finance and this kind of domains, right? So you need to have some data where you can run, for example, a lot of checks in order to make sure that this data is consistent and you can trust it even at the detail of the unit, right? But if you're doing another kind of task, for example, you're building a classifier for sentiment analysis over documents, that's a completely different game because in this case, you can compromise with having some documents that maybe are a bit messed up in the English syntax. They are lacking, there are extra characters because those are extracted from the web. So you're also extracting the XML or the DOM behind it. Or, these kind of errors are completely fine because the deep learning model will be able to handle these and recognize that it's noise, and it can give you a good sentiment label anyway. So in my career, I've been mostly working on relational data, and this is a setting where we assume that we want to have the data as accurate as possible. There are different approaches for doing this. Some are based on logic. For example, you have some rules and you want to enforce them so that you say, okay, if all my rules, logical rules, my checks are validated, I tend to trust the data. There are also other approaches that are more inspired by machine learning, such as outlier detection, duplicate detection, and those are all tools that are all used by the people building the pipeline for having data to process. Now, you mentioned the term scalable. That's important because in some setting, this data does not fit in memory. It this is a traditional problem where you want to deal with big data. And so when we say that we want to build scalable solutions, it means that we don't want to assume that the data will fit in memory. And this raises a lot of challenges from the system perspective because you need to design algorithms that can run using both the disk and the memory. So for example, instead of using something that loads everything in memory, you want to have something that can process data in chunks, different steps, so that you can use, no matter what is your memory size, you can still process a large amount of data. Does it make sense?
Yeah. What about you, Tommaso? Would you like to add something?
Well, as you well know, this is not exactly my main topic. And specifically, I don't really know how it works underlying. So in this case, I don't really have anything to add for you. I'm sorry.
So is it what you, because on your website, you have this quote from Einstein, which is everything should be made as simple as possible, but not simpler. Is it what you mean when you were talking about the data quality?
So I like that quote because it covers a lot of different aspects in life. So one that it's very relevant in academia is that sometimes we tend to create solutions for research problems that are big machinery, very, very powerful, to solve a problem, because this will give us the better gain and they make sense to us to create this complex solution, very sophisticated, very smart, right? We try to look smart and create smart systems. Now, this is a bit in contradiction with a lot of evidence where sometimes you can find solutions that are much simpler and you get comparable results in terms of quality. So this is something that people coming from a system perspective tends to like a lot, because if you have a simpler solution, it's easier to deploy, to optimize, and to manage over time. And an example that is very famous in the last few years is when you try to do inference from tabular data. So imagine that you have a table, you want to do verification, for example. So in the last 3, 4, 5 years, people have built a lot of huge machinery based on deep learning. I also wrote a paper on this for data imputation, when you try to impute values, missing values in a table. And it's, it's very tempting, because now you have this deep net that, they are shining in many, many applications. So why don't we apply them directly also on tables? And the reality is that it's not so clear that it's worth it, because now you're using a deep net that consumes a lot of energy and GPU. But if you use a solution based on trees, XGBoost, you get comparable results. And it's a much, much simpler solution from the point of view of the design and the energy consumption, the GPU cycles, etc. So this is something that I always try to keep in mind, that, this little benefit of 0.5 points in your quality in the task that you're doing, is it justifiable when you have a baseline that is much simpler and is, consuming 2 orders of magnitude less CPU cycles or energy. So that's one important facet of this motto.
Okay, I get it. Okay, I'm just wondering, maybe you both are gonna be able to answer this question, because you are both working in research. How do you use AI in your daily life? Do you use it for some LLM model for your own research or not?
Tommaso, do you want to go first?
Yep, and this is on this matter I can answer. So I do use not one but multiple LLM models. I do follow the world of marketed AI at the moment, and I know that there are some models that are more suitable for some tasks instead of others. And the main usage is not for writing code, as it might seem counterintuitive, but it's for actually performing rewriting of text and confrontation. So whenever I have some idea or doubts, before talking with another person or with my supervisor, another researcher, I try to give it an input to a couple of LLMs and see if it makes sense. Of course, you have to do this by knowing the limits of the LLM. So you know that it can hallucinate, you know that it can give you some very random things that are completely unrelated. But if you know the topic that you're working on, you know what you're doing, then this actually acts really well as a catalyst. So you really simplify the starting point of a lot of works, a lot of jobs. This is my main usage at the moment of LLMs is this one. I cannot really use it for coding because my work involves a lot of low-level IoT related code that unfortunately it's still out of the capabilities of those LLM. Hopefully they will manage to keep up in the near future, but for the moment I cannot really use them for coding. But in the research, for the research itself, I really feel like, especially with the latest updates and release, it really can help a lot as a catalyst for the research job.
Yeah, so I think that we are more or less aligned. I mean, I like to use LLMs as if they are some interns. So people that can be very helpful, can help me scale on different things, but they're not fully trustworthy. So you need to manage and monitor them and verify the output. And I think that it is a common experience for everybody, right? We know that we cannot just take it out, the output, and put it in something that is important. However, as Tommaso mentioned, there is indeed value, and value in validating ideas, values in doing quick literature review. It is a very delicate point because sometimes they can hallucinate, but I found some cases where they can help me find works that I didn't know, especially in topics where I'm not very an expert, right? There's always this use where I find it very useful in things that you're not an expert, like Tommaso was mentioning. He's an expert in a obscure coding language, so he's better than the language model, but maybe now he's asking questions about Java, which is not his expertise, and the language model can speed up his productivity, right? Can improve. For these common sense, very well-known topics, it can be very helpful and sometimes you can save time. Now, I think that it's also interesting to turn the question to Baptiste because he's the one doing exams and assignments. So what is the use of LLMs that you do?
I kind of use it almost every day. It helps me to understand all the courses I have. It helps me to have some application of what I learned. I used it also for doing this podcast. I used it because I need to be really organized and have a plan and to prepare a plan. So it kind of helps me to organize my thinking. So a bit like you. At my level, I don't see. I can't see the hallucination of the model because I don't ask him too complex things. However, when during the summer I developed my own software with another student of Eureka, and we used a lot of API, and then we have experimented the hallucination of AI. But yeah, it helps me to be way faster than before and more effective on my everyday tasks. But which model do you use? Because you told me that you kind of try a lot of them. Do you see any differences between the most known model?
So at the moment, I'm using ChatGPT and Gemini, of which Google kindly offered a pro version for 1 year for free for students. So one of the things that you need to use to differentiate them is something that is called the context of these LLMs. Paolo knows better than me for sure, which is basically the quantity of stuff that you can give them and that they can keep in memory. This is a very high level explanation. So, for example, Gemini has a much wider context acceptance rather than ChatGPT. So, if you want to have it process, I don't know, a very large code base or multiple PDF documents, you're going to choose Gemini from Google over ChatGPT because you can see that maybe you give to ChatGPT a 10 pages PDF and it cannot go past the information at page 5 because it simply cannot parse. It doesn't fit its context window. So depending on the task that I have to use, I use the different LLMs. Then they also there are a lot of benchmarks online. Those are public. There's a very fancy thing called LLM Arena, in which they compete, they make the different model compete for different tasks. So there was a certain point in which ChatGPT 5 version thinking, whatever, was better in English writing than the others, then Gemini Pro with internet access is better at a coding bench. So if you want to write code, depends still which code you want to write, it is better. So depending on the use case at the moment, I just switch between them.
Yeah, I mean, I agree that there are differences. These differences, in my experience, they are not super radical. And the explanation I will give is that behind they share a lot of the techniques that they are using. The main techniques to build these models across the different labs, we know for sure that the main, backbone and main ideas are very, very related. But what is interesting is that every few months there is a new breakthrough or a new idea that becomes immediately is secret for a while, then becomes somehow understood by everybody and everybody replicate it. And I think that we also this very clearly with the thinking, right? It was something that came up, this idea of creating this blurb of reasoning to improve the final response, to condition the final response. We also that it started about a year ago with OpenAI, and then DeepSeek made it public, and now every single language model is doing that, right? And we saw a big bump in many applications thanks to this new idea. And what's interesting is that we don't know what is going to be the next idea, right? I personally believe that the transformer has still room to improve. I don't know what is the limit, nobody knows exactly, but there is still room for new ideas and more progress. But what I will expect in the next few months, I won't dare to go towards the years, but in the next few months, I expect that the biggest contributions are going to be in the realm of the efficiency of the model. And it's also related to the context, Tommaso, that you were mentioning, because if we make a better mechanism for the attention, then we can afford to have a bigger context, and we can afford to scale up the inference of multiple processes on one GPU. So this is something where I believe we are still in the first steps in order to make these models really usable and cheap. Because now we know that they are extremely expensive, but I believe that there is room to optimize. I think that if we go back to the analogy of the big machinery, I think that we are still in the situation where we use this big machinery, but we use only a small amount of the power of the machine, right? And but it works, and we're all happy. But we're using a big machinery, so I believe that it's already happening, and people are getting better in isolating the part of the network that it's going to be triggered to answer a certain question. So instead of using 100 billion parameters, we use 10 billion parameters to answer, right? So this is already happening. And this kind of innovation, I think that is something that we will see a lot. And we will see this model able to scale up also because of this more efficient approach. But who knows what is going to be the big next idea that is going to give us another bump in the benchmarks and in the quality.
Okay. Maybe what would be interesting now, because we get the mindset behind your work. Maybe I would love to know more about about how you actually apply in the real life, in the real world. I mean, what was the concrete solution you have developed? What kind of tools you have helped to develop to fight misinformation in your work? So. So to be clear, what would interest me would be what happens after the research paper is published, and how does it turn into a tool people can actually use.
I mean, I'm happy if Tommaso has also comments on this. I think that the big picture is in academia there are different kinds of impact. One of the most the easiest to measure is of course papers, and that's what we usually measure. But as you are suggesting, we also try to have impact with software that we develop, benchmarks, and code that people can use with some kind of tool. So in my experience, one system that we developed was thanks to a PhD student that at the very beginning of COVID, we were working on computational fact-checking for some energy data for an organization. But basically, when we say computational fact-checking, the idea is that you have a claim in some language, in natural language, and you want to verify this claim against some sources of data that you trust. Okay? And our angle, given my expertise in databases, was okay, let's try to do verification of facts based on some structured data, some tables. And so we found that, they started to create public data about the spread of COVID, and we were able to create a tool that could verify claims about COVID-19 in terms of spreads, number of people infected, the number of people dying, and all these sad stories of the time. So this was one example that got a bit successful because we created an API and different fact-checking organization, people who were doing at the time verification of information for social networks. Now it's a different story. But at the time there were multiple organizations and they use computational methods, and they were using also our computational solution based on this idea. So that's one direction that it's quite visible.
Yeah, sure. Yeah. If you have a question before me.
No, it's okay.
So from the point of view of the work that Paolo has done, cannot really speak, but ideally a researcher, when, at least for me, when I write something, when I'm working on something, the ideal thing would be to produce something that is actually useful and that hopefully will be used by the community, by everyone. So if you think about research in medicine, you produce something that probably is going to change the world. And that's one level. Research in AI, in LLMs, as Paolo was discussing before, one day some Chinese researcher from DeepSeek, they decided to publish the paper about thinking, the reasoning feature. That paper is completely changed all the world, basically. Then, of course, this thing scales down because not everyone can produce breakthrough research like this that is going to affect billions or millions of people. But ideally, a researcher would like to do something that is valid to something, at least in my opinion. Like, I would like that my work produces something that then is helpful to somebody, at least. It can be a small community of people, of security researcher, can be all the world, because all the world is using AI. But at least you have to, I don't know, if you are not driven by these, I don't know what else drives you, because that's my main point for researching. I would like to produce something that other people see and say, this is good, this is useful, this is.
I would like just to add two micro comments. One is that the way that I see a PhD is that you want to create knowledge. And it's intentionally very wide as a term, because knowledge may be a new data set that people use for training or for benchmarking and enables something. Or it can be a theorem that enables you to create something new because now you know that it's possible. Or it can be a system that people use as So there are different declinations depending on the community, the team, the lab you're working on. And I believe that all of them are valid. Another aspect that maybe I want to correct, because maybe I was not clear earlier, is that when I was mentioning that people measure papers as outcome, it's a reality, but I'm not saying that it's the ideal world. And I really liked when I was in a lab in the US, somebody who told me, here we see the papers as a side product, in the sense that we do research, we build stuff, and then this is something that is working and it has value. And then the paper is a side product because it's how we describe what we built. Unfortunately, there are many people who don't reason this way. They reason in terms of, I need to craft the paper, and then if the code is not running, is not available, does not exist, this is less important. That's a discussion for academics. Maybe it's not interesting for everybody.
Yeah, I mean, as you said before, it's about creating knowledge. Everything else is a side quest, I would call it.
Okay. And Paolo, you mentioned doing research in the US. What would be the main differences between there and here in France or in Europe, mainly?
There are many, many big differences. Let me see. One that is really important nowadays, I think that is the means, and this applies also for China, by the way. The fact is that we are, especially when you look at the generative AI language models context, right? It's a playground where you need to come with the right toys and the right amount of GPUs, energy, workforce, etc. And the difference in many places, of course, we cannot, there are exceptions. But in general, the workforce, the amount of energy and the amount of money is different. So this can affect the outcome and how easy it is to move and to have big breakthrough. I think that especially with the US, there is also a difference in perception in the sense that this applies at least for Italy and France. But there's a perception in the US that if you're doing a PhD in computer science, if you're doing research, you are an important person. Okay, so take it, in a very generic way. While in Italy, when I was working as a professor in the Italian university, most of the people see you as somebody who's stealing money and wasting his life because, it's not a prestigious job. So there is a perception also that, the value of research, at least computer science, I don't want to generalize, is different. And I think that this is reflected also in the importance that we see, right? From the different companies, the different outcomes. We have Mistral in Europe, that is our leader representative of LLM, generative AI company, while there are dozens across US and China. And I'm old enough to remember 20 years ago when I was giving a talk in a company that was built in Europe to have the European Google. Because this is not just a matter of money, it is a matter also of shaping narratives and culture. Because if you have, at the time, a search engine, now a language model that is created by actors that have their own moral, cultural principles and their own political interest, they are not aligned with your country, with your European Union, for example, right? So there was this urge to we need to create our European search engine because so that we are not in the hands of Google. You know how it goes. It went, right? I mean, we don't have a strong European search engine. And we are all afraid for the language models, right? I mean, we are big in my lab, in many, many labs. We are all big supporters of the open models coming from China. Qwen, DeepSeek, and many others. They are amazing because they are top of the line frontier models and they are open. So we can play with them, we can build on them, everybody's happy. However, we need to be careful because these models, they are heavily censored. If you try to ask questions about what happened in China in the time of a crisis, they refuse to answer. It's not a big deal, this specific episode, but in general, this is going to shape people, young people, and also people like us who are getting information out of this, and we're getting information with bias. So I think that those are important topics that we must be aware at least.
Okay. Just, I'm curious. I've seen that you were recently awarded the 3IA chair. Not sure to pronounce it well. What is it basically, and what are you working on actually nowadays?
So this is a chair, which means that the 3IA, which is a consortium of different actors in Côte d'Azur, in Sofia Antipolis, in RIA, the university, Eurecom, and many, many other institutions. They come together and they create some packages to promote the research of some professors. So it's a competitive title. They gave me this title and support for hiring some people. And the center of my research in this case is trying to fight a little bit what I was mentioning a few minutes ago, right? I mean, the big narrative coming from the biggest players is that, we're going to have one or few models, they're going to do everything. You don't need your own model, you just go to OpenAI or Google and it's going to be so great and you're going to use it. Now, what we are trying to do in this chair is a bit the opposite, because we believe that even if you have a small model and you train it specifically for your use case on your own data, you can get performance that are comparable to the biggest model. Now, why this is important? It's important for two reasons that I want to stress. One is the privacy. Because if you have a model that is 7, 8 billion parameters, you can run it on a relatively small GPU, which run on Eurocom servers. So your data is private. It is very important for hospitals and whoever has sensitive data. And I believe that we all have sensitive data to some extent. And the other point I want to mention is that if you can use for your own question a small model, you are reducing drastically the reliance on large GPU and the amount of energy that you need, and therefore the pollution, the energy consumption. So I think that there is a narrative that it's worth exploring and research that is worth doing, because if we manage to have small models that are personalized, I think that it's better for privacy, energy, and we don't have to believe the story that we all need to rely on the big players and just trust them forever and ever in terms of privacy and all the problems that you can imagine.
Okay. And I've heard about the project Squab, right? What is it? Because I've seen that and been really interested in that, because the topic was to build a crash test with the ambiguous or unanswerable question, in which you teach them the humility to say I don't know instead. So is it related to what you are doing right now, or it was a previous project?
So this is something that we did because my experience, and I'm also curious to hear your experience, but when I look at the case of failure of a language model for something that I need, in many cases there are two patterns that are happening. In one case, my specification of the problem was not clear enough and the model went in the wrong direction. So it was not giving me the solution, the answer that I wanted, because my question was underspecified, open to multiple interpretation. Or another problem is that the model will try to answer anyway, even if the question that I'm asking is something that is not in the knowledge accessible to the model. I think that those are two patterns that maybe you have seen using language models. So what we wanted to do with this project is to put our finger on this problem. So there is a benchmark generator system that, given some data, will create a test to show that, okay, are the models able to recognize ambiguous cases? Are the models able to abstain from answering instead of bluffing and giving a wrong answer? So I don't know, those are two patterns that are close to my heart, and so we wanted to really benchmark the models, and we showed that models, they're still not there. There are many cases where the model will try to answer anyway, and I think it's important to benchmark this in a scientific way to be able to track progress and to push for models that we can trust.
Okay, nice. Maybe you would like to add something, Tommaso?
No, honestly, not on this part. I agree with Paolo. And it's
Okay, so I don't have other questions. I mean, I think we have done the round of your main topics and the issues you are working on. So thanks a lot to have accepted the invitation. It was a pleasure to talk with you.
Thank you so much, guys. Looking forward to hear all your episodes. Good luck.